This podcast is supported by Siemens, your partner for industrial-grade AI.
Hello everybody and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber and it's a pleasure to talk to
Peter Seberg. Good morning, Robert. Good morning, afternoon, evening to you, dear
Good morning,
listener.
Peter. Today's main topic is safe AI in industrial application and the role MathWorks is playing in this field. But before we talk about safe AI with Lucas in the main part, please, what do you have? Share your news with us, Peter.
Well, I hear that you went to see the Pope.
I met the Pope, yeah.
Now, this is not just something out of your personal life. I do not want to hear, but there is some kind of relationship with artificial intelligence.
Exactly. I was in Rome and witnessed the new Pope's first prayer, and he had a surprise for me. And I have a quote. I will share the quote with you. So, I chose to take the name Leo the 14th. There are different reasons for this, but mainly because Pope Leo the 13th is in his historic encyclica Rerum Novarum addressed the social question in the context of the first great industrial revolution. In our own day, the Church offers to everyone the treasury of her social teaching in response to another industrial revolution and to developments in the field of artificial intelligence that pose new challenges for the defense of human dignity, justice, and labor.
Yeah.
Amazing, the Vatican is now also getting involved into AI. Yeah.
You just happened to be there standing on the main square in
San
front
Pedro
of the
Cathedral,
church. That's amazing. And then what do you think? That sounds like almost not a personal, but at least you could very closely relate to what he. And maybe you must have been.
It's absolutely surprising. On the other hand, it's not surprising because yes, he's right. That's another industrial revolution, right? And it will change everything. Yeah, it will change everything. But now he's also into this game. Yeah.
That's amazing. Yeah, I say that many times, we're never about politics and we're also not about religions, but here we are. And we're not talking necessarily religion in this case, but I saw the same thing. And there was a discussion we had actually here in Germany on the very same topic of the church and the church being almost
NGO.
Like political.
Yeah.
And here you go. And he chooses the name of the other pope, as you say, who
Leo.
lived around 1900, I believe. And he dealt with the implications of at that time, industrial revolution, which today we call the
first industrial.
That's maybe what we would say the first industrial revolution, right? Yeah, right, exactly. And he knows about this. He knows about this. And in his first talk, he talks about, and that is not necessarily so positive. I mean, he says, we have our own potential issues, right?
But it's interesting because he studied also mathematics, so the Pope maybe knows a bit about when it comes to artificial intelligence.
Wow. Oh, I didn't know that one. Oh, yeah, maybe. Yeah,
he studied mathematics. I think he has a bachelor in mathematics. Then he decided to change his career plans. Yeah.
Wow.
Yeah. So it's
sure. So this is the introduction for today. I do have 2 other topics, and I must say they go into the same direction. So the first one I had is called Absolute Zero: Reinforced Self-Play Reasoning with Zero Data.
Okay.
You see that yesterday? There's a paper by students from 2 Chinese, so Tsinghua, if I pronounce that correctly, University, as well as Beijing Institute for General Artificial Intelligence, and Penn, I think that's how you call it, Pennsylvania, Penn State University. So it's all about large language models setting their own exams. That's the way to think about it. So as per the title, the base algorithmic approach is about reinforcement learning. Now, you and I, we talked about this 5 years ago. Then we paused because the world paused on RL as far as we are concerned. We didn't see. And then it came back just a year
with Jan
ago.
Kutnik.
I think it was called something like RL for, verifiable award. It was about trying to reduce hallucinations. So you tell the large language model, so this is a good answer and this is a bad answer. And what you should always try to go for is the good answer, which is then, of course, good as far as humans is concerned. That's the topic that this is all about as well. So now, what that needed to be then, that humans needed to provide always, a huge collection of questions and answers right now. And now I'm going to give a very short quote from this paper. It says, in a hypothetical future where AI surpasses human intelligence.
Back again to the Pope. Yeah.
Task. Well, no, really. Yeah, sure. Most. I mean, it always is. All these things always happen at different parts of the world. Tasks provided by humans may offer limited learning potential for a super intelligent system. Let that think in. They're already at a point where say, the AI is not going to care. And I'm going to finish today with another topic along exactly the same lines. And now they say, to address these concerns, we propose a new RLVR paradigm, and they call it absolute zero, right? In which a single model learns to propose tasks that maximize its own learning progress, and then improves reasoning by solving them without relying on external, and that's what I say, without human data. Now, why is that important for us? I want to share one quote by Armin Hatzalic from Siemens, who brought me actually to this paper. And he says, picture a factory line that writes its own test questions over lunch, aces them before the next shift, and ships a smarter control algorithm by dinner. I think that's a very wonderful quote. I mean, you bring it all together. It's always about, oh yeah, and there's Peter again, and maybe Robert, but more so even Peter, always looking into the future. And then this, poor Stefan Sulak and all you other guys and girls out there who, as soon as you listen to this and get out of your car or out of your public transport, you're with your clients and you need to build something, and they will tell you, oh, but Peter and Robert told us that
and we need to talk to the Pope too.
The Pope told you as well, yeah. So very, 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 very sorry for that. I think today we're looking at very much. Now, as I say, this paper, so we started with the Pope, and then we have this paper, I repeat, hypothetical future where AI surpasses human intelligence. And, I make room for you, and then I'll come back with a final one along the same
Me too, because I have another spoiler. Jakub Tomczak, Peter, will be our US correspondent and will report regularly from the US. And I had the opportunity to record with him yesterday an episode, and it was a very interesting episode, but because he said LLMs will become the basic technology for many other topics when it comes to AI, and if we are capable to combine, for example, LLM technology, agentic applications with time series application, etc., then we are on the path of AGI. And more that in a few weeks with the first episode with Jakub, but it's the same direction as you mentioned. Yeah.
Exactly, it sounds like. Now, it's only a year ago I would have said, what have you been smoking, or what has Jakob been smoking? But I must say that was kind of my line here between what I've been seeing is like, there's ever more people around us are going this direction, right? So if you want to, that's an amazing announcement, by the way.
I'm very proud that he said, yes, I will do that. I will report regularly from the US all 5-6 weeks. And it was very interesting. He shared, I have one more spoiler, because he said a big topic in the moment in the US is to think about the data and to have good data. And because they are running out of data in the US to train their models, etc., they need new data, they need more data. So the whole data discussion we had in Europe 2 years ago, we don't want to share data, is now coming back in the US because they have no data. And he said that VCs, for example, venture capital companies, only give money to people who also have data, not the model. important. You also have to show them that you have the right data for the model and that you can run the model with the right data. That's interesting.
So not only the Pope is coming to the US, also the data is coming
Back
to
again.
the US.
Yeah.
The discussion. Very interesting, because I just finished up preparing for tomorrow my discussion with Thomas de Hollander. He's a time seer AI, and it's all again about data along the lines of what Andrew Wang has been saying, right?
Jakob also mentioned Andrew. Yeah.
Okay, there you go. Really looking forward to be hearing from Jakob directly out of
Exactly.
Silicon Valley.
Last news, Peter?
I'll finish then with Peter Gostev. Peter Gostev, if you don't know him, he's a great guy who makes LLMs understandable, also comparable, I would say, for all of us. And he says, quote unquote, he's very excited to announce a new venture along the same lines as we said, Proxy Human, it's called. It's a marketplace for AIs to hire humans for tasks that AIs just can't do.
Oh my God. Oh my God.
Let it sink in. So he says, need empathy, you need a sense of smell, or you can't solve the pesky captures.
It's a joke.
Hire a human today.
Is it a joke? No.
You're never sure with Peter, but the point nevertheless is, even if it is, and then he finishes saying, so if you are an AI, and then he says, judging by the amount of AI-generated comments I see here, there must be many around today. Don't wait and get in touch today. Serious inquiries only, no humans, please.
I think it's a joke.
You really think so?
Yeah, I think so. I think so.
But the point, nevertheless, is I think that's where we are standing today. As I say, I mean, I've been saying, but I'm not sure how we called it in the past. There have been a number of different terms, right? What's the name of the guy who invented the synthesizer? And he came up with this idea the first time, and he said, "Oh, I'm very close in my brain now." But then he called it a name. He said, 2043, we're gonna reach this singularity. There's the word. When we first talked about it, and we talked about it in our book, and there's another book that I did as well, and then it was called Singularity. And there was a friend from Australia, I believe, who did another book, and he asked all the people at that time, and he didn't say 2043. I think he said something like 2036. And it was all about, oh, yeah. I mean, who's going to believe it? Singularity is what he came out with, if you're still looking there. So what can I say after this? Are we looking in the future, or are we already there? I mean, in a day where AI has not yet completely surpassed human intelligence, but you're not sure all the time these days already, right? So we seem to be in a mode of, what is this? Is this a human? Is this an algorithm? Is this where are we moving?
So Peter, let's move to the main part. Coming back to the industrial processes, safe AI models for the industrial processes. And I was very surprised that this is a MathWorks topic.
I heard that, right. Yeah, I heard that you were surprised, yeah. Mm-hmm.
What about you?
Well, as he was explaining, I mean, it's based, I mean, we've been talking from several sides on safety, right? You were at a conference with SICK, I believe, at the time, and we've talked to many people. We're gonna be meeting with the Spleen Lab guys in a couple of months. At that time, when we announced DIM half a year ago, we were very surprised, because it was all about, is probability-based safety possible at all? ? Exclamation mark. And then I believe the Spleen Lab guys, they even have a patent, something like that. So that is a topic. And I've been reading a lot about what MathWorks is doing for another topic there. And of course, in the end, whatever one of you engineers out there, and you must be thousands, really thousands, and almost all of you engineers from wherever in the world you are have at least been involved with, have been attached to, been using the MathWorks tools as part of the university program, because that's their setup, right? That's their deal. And from that perspective, whatever you have been designing, and independent of the fact that you also, in addition, have been moving to machine learning, Python, and whatever, many of you, still keep it as the center, some of you as an addition, but whatever you are designing these days needs to be safe. And
one quote,
of course,
MATLAB and Python, the best of both worlds. That was one quote.
Oh, that's his quote. Yeah, exactly.
Yeah, exactly.
And whatever comes out, of course, we need to make sure that you, as engineers, need to make sure that you desigin whatever, a safe coffee machine or a safe autonomous vehicle,
exactly.
And whatever is in between. So I did listen already. I thought it was a very interesting episode that you did there. And I wish you, dear listeners, interesting hearing.
Thanks a lot, Peter. It was a pleasure.
Robert, thank you very much. Have a great day with or without
the Pope
having been passed by artificial intelligence.
Thanks a lot. Bye.
Take care. Bye-bye.
My name is Roel Weber, and it's a pleasure to talk to Lucas Garcia, and he is the Principal Product Manager AI at MathWorks. Hello, Lucas. Welcome to the podcast.
Hi, Robert. Thanks so much for having me here.
You're welcome. You're based in Spain and you have a PhD in mathematics. That's for sure. When you want to work for MathWorks, you have to have a PhD in mathematics. But before we start, please introduce yourself briefly to the listeners.
Yeah, thanks, Robert. Yeah, hi to all the Industrial AI Podcast listeners. So my name is Lucas Garcia, and as Robert was mentioning, I'm a product manager for AI at MathWorks. I'm a mathematician by training. I did my PhD in neural nets, maybe back in the days where neural nets was not such a big hype.
So in the 90s? In the 90s?
Later than that. But yeah, I guess I have a genuine passion for math and AI and coding. Okay. And yeah, this is why I joined MathWorks, I guess. Yeah.
Okay. Yeah. That's interesting. When we first spoke and we talked about our episode and what we want to discuss, you talked about safe AI and regulation, and I was completely surprised because you work for MathWorks. How does that fit together? Regulation, safe AI, and MathWorks?
Yeah, it's been a bit of a journey. So maybe I can. So yeah, in my tenure at MathWorks, I started as a customer-facing engineer. I worked with MathWorks customers in training them and guiding them, supporting them on how to use the MathWorks products. And then I moved to product management. And as a product manager over time, I've focused on this area on verification and validation and Save AI. That is an area that I'm very excited about. And yeah, this is what brought me to talk to you today. And so yeah, I understand the question, right? So how MathWorks got involved in all of this. And I guess, maybe the most obvious answer is
it's a customer demand.
It's a customer demand. Our customers rely on the software that we build to develop engineer systems. And in those situations, safety is everything. Think of an aircraft collision avoidance system or trajectory planning and control in a vehicle that, has been used in traditional software for many years. And these are areas where AI can offer also very efficient possibilities, and there's an increasing interest in using it. But safety can be questioned. Right?
Absolutely. Safety is a huge topic, right? You have to bridge the gap between AI and safety, right?
Exactly.
You are heavily involved in the whole safe AI community. Can you give us first an update? What's happening with regulation right now?
Yeah, so the regulation is definitely evolving. So regulatory affairs are moving fast. Also, this depends on different countries and where you're looking at. And it may sound hard to believe, but there are actually more than 400 standards related to AI out there today.
How do you handle that?
I cannot mention all of them to be true, or even remember them. But there are a few great.
That was your exercise to do that.
That was a bit of my exercise, correct? But there are a few great sites that consolidate this information. So if anybody listening wishes to take a look, one of the places I like to take a look at every now and then is AIstandardshub.org. And maybe I can give a bit of a
in the show notes we can share all the domains. Yeah,
maybe I can share a bit of a background there. So I'm a visual person, and so I like to visualize this regulatory affairs and standards and the certification. The one picture that I typically use is this, a pyramid with different levels, right? And each level builds upon the last to ensure trustworthy AI development, right? So typically at the base, we see government regulation. So we are here in Europe. So the EU AI Act sets these broad ethical and legal frameworks, and they categorize AI by risk and enforce, stringent requirements for, especially for the high risk applications. Above that, we see another step up, maybe with international standard bodies like, the ISO standards or the National Institute of Standards and Technology. And there are standards that are more broad. Maybe they speak to how to manage AI or how to work with functional safety in AI systems. I like then to look into the next year by specifying more like industry-specific standards. And these
Maschinenrichtlinie. Yeah.
Exactly. So he speaks to the unique needs of sectors like aerospace, industrial automation, machinery, automotive, healthcare, and here we see various different standards too, right? And then maybe at the pinnacle, we are seeing specific standards that relate to very specific needs of AI verification, things related to robustness, and how the models need to behave outside of the training data that has been used, right?
What are you discussing right now in the communities, in the safety communities?
So MathWorks is part of various working groups, international working groups that are putting together these standards. So I give some examples. So for instance, we're part of the international joint working group with EuroK and SAE that is putting together a standard for aircraft systems with AI. And this is the ARP 6983 standard. And the goal is to basically address the current standards we have in software when it comes to developing such, aircraft systems. And in this context, we have been working in this project for, I think, over 5 years now. And we're close to publishing the first version of the standard. We're hoping we have a tentative release date by the end of 2025. This has been pushed a couple of times before, so it's a little bit unclear if we will be able to maintain that release date. On top of that, we've been working with the ESA, the European Space Agency, working on a new standard for space applications. This is the Machine Learning Handbook. And what's interesting when we look into this space, whether it's automotive or aerospace or machinery, or is that in situations where safety is paramount, there are these common threats, right? You typically find these common situations where people are interested in understanding requirements. What does requirements mean in the context of data? What does it mean to have high quality data? What does it mean to have good coverage of the input space? Are you adequately representing your input data or your operational design domain? And those things become very, very relevant even before training the AI models. I think that, as someone who has been working in the field of AI, I've seen, and I think myself included, right? We've all been very tempted to, whenever we get some data, let's train something, right? And
let's try out.
Yeah. And in these situations where safety is of utmost importance, you probably need to take a step back and think through about some of the very important aspects of the workflow.
We talk about the workflows a bit later, but I want to come back to the regulation and safety communities, because I met a Bosch colleague a few months ago, and he said China is now the leading regulator all over the world. Europe was, and he sees a lot of Chinese companies, and the Chinese government regulates a lot, regulates everything. If you have an international standard, they add a Chinese standard on that. Can you confirm that?
It's a good point. I'm not that familiar with the Chinese regulations. I did look into these in the past, but yeah, I think it is certainly possible that on top of existing regulations, governments can enforce more restrictive or less restrictive depending on their needs and their wishes. What is clear for us at MathWorks is that when we look into the different industries and the challenges and the needs that customers are putting in front of us, there are gaps with existing standards, despite mentioning there are 400 standards out there, right? There's still gaps in some of the standards. There's sometimes lack of knowledge in applying these standards when it comes to AI. And so I think this is the gap where we at MathWorks, we're trying to support the community, and we're trying to find a way to provide a comprehensive workflow to address this.
You already mentioned your company. What is now your approach? Feel free to go into details. What is your USP? What does it mean for your industrial customers? And how do you make money out of it at the end? Because you're not there to have a coffee at the community. So you want to have a product and you want to make money out of the product. So what is your approach?
Yeah. So, MathWorks, well, maybe just as a quick recap for people in.
Oh, I think the most listeners know what MathWorks is.
In the audience. I think everybody knows, but we're creators of MATLAB and Simulink, right? So MATLAB is basically programming, numeric computing platform. It's used by millions of engineers and scientists, and they use it to analyze data, develop algorithms. They create models, and Simulink is a block diagram environment, so no coding required. It's used to design systems in these multi-domain situations. The models can be simulated before moving to hardware, and you can deploy them without having to write code. Now, because of our tools are used by engineers and scientists today to build all kinds of engineered systems, aircrafts, automobiles, machine tools, etc. We found that there was this urgent need from our customers to help them understand how AI could fit into this picture, especially when it was involving critical or safety critical systems, where regulation was starting to become a bit more relevant, but still unclear. And of course, this is not something MathWorks can do on their own alone. This is not something anybody can do alone. When we look into the working group for aerospace as an example, there are plus 500 organizations contributing to the development of the standard. So it's not something that a single organization or institution can do. And so we started contributing to this working group. We have a team of developers who have, I think, when we first looked at this problem, we thought, when it comes to AI safety and when it comes to understanding the gaps and the challenges that our customers are facing, the best and really only way for us to figure it out is just to try ourselves, right? So we had to try ourselves the complete end-to-end workflow, from defining these requirements that may be data-driven requirements, they may be data-related, going through the entire development workflow with our tools, and maybe also with other tools, and understanding what was required. And this allowed us to co-author some publications. So there was this joint research between the Technical University of Munich, MathWorks, and NASA that was mainly carried out by my colleague Konstantin Dmitriev. He's a developer at MathWorks. He's also a research associate at TOM, and he basically showed how this AI-enabled system could work in the context of existing regulation in avionics, right? Which was a bit of a question mark. So yeah, we at MathWorks, we provide tools, we provide services for our customers. We want to do the right thing. We want to make sure that our customers are successful and happy at the end of the day. And so to make sure we were able to get there, we started contributing to these working groups and standards.
But what does that mean for your product now, for the MathWorks environment, for the customer? What will change, or what would already changed in the workflows?
Oh, okay, yeah, that's a great question. So maybe just a step back on the workflow. like I said, I'm a visual person, so I think this is it's always hard to depict through audio, but I'll do my best. So, in the development of traditional code, I think the V model or the V cycle has been one of the most used frameworks or structure frameworks in software development, right? I'd like to start there. So this V model basically is this structure approach to guide the process of designing, building, testing complex systems, and its name obviously comes from this V shape, and it visually represents this relationship between development phases on the left hand side of the V and the corresponding testing phases on the right hand side, and it starts with requirements and it goes through you go through the entire V cycle. We implement the system or the component, and we verify that it has been correctly implemented, and then we validate it. Now, this process basically ensures that each stage of the, let's say, development process is systematically verified. Now, when the same process is used for AI, this does not always work because the AI models introduce these unique challenges in the cycle.
Which challenges? Can you name a bit?
So, for instance, like unlike traditional software, like we're thinking of a deterministic approach, and where we follow explicit rules defined by the developers, right? AI models are data-driven and learn patterns from training data, and so this means that the behavior can be unpredictable, especially when we find scenarios that are not represented in the training data. As I think we all have maybe trained an AI model and then we tested it with some independent test data, but then when we put it out in the field, it's not performing. And so, as a result, verifying that an AI system meets its requirement isn't as straightforward as checking against some predefined specification, right? So for these reasons, various adaptations of the V workflow have emerged to better suit AI. I like the W diagram, which is, I think, because it's simple, I think it's easy to understand. And this was proposed by EASA, the European Innovation Safety Agency, but has been adopted by many industries, and I have seen it across many different white papers. And it's basically this modified version of the V cycle where in principle, it maintains the V structure, but it includes basically an additional process. That's the peak of the W, I guess, to manage the verification process that needs to occur after the model has been trained. And so what we've been working on at MathWorks is to enforce and make sure that, our tools, MATLAB, Simulink, our add-on products, they support each of these steps within this diagram. Because ultimately what we want to be able to do is we want to make sure engineers and scientists, they can train, they can verify, they can test, they can deploy models, and they can do this with confidence. Right?
And you brought up the topic of data at the beginning. What are you doing there when it comes to data?
So maybe one thing to understand is that when we're working with data, we need to understand what are the operating conditions under which your system is designed to operate in. And not only that, but what are the operating conditions under which your system is designed to operate in safely, right? That's the most important thing. Where are the edge cases and so on. So this is often referred to as the operational design domain of the problem or the system. And in this case, what we want to be able to do is we want to be able to outline the environment, the scenarios, where the limitations, where the system can function without human intervention. And so you can think of very basic ideas like, environmental conditions, right? You need to be able to describe the weather conditions that the system can handle. Can it handle rain, snow? I'm thinking of maybe a automated driving assistance system or something like that. How about lightning conditions? If we're at a factory, what are the lightning conditions that the AI system is expected to be seeing? Because changes in the lightning conditions, we can talk more about this. Changes in the lightning conditions can, significantly affect the output of your AI model, and so on and so on. So you start to define what are the components of your operational design domain, and this can be, this is often done at a description level, and then we can start to collect the required data. Right. When it comes to vision-based applications like the ones I'm referring to here, it might be more challenging because it is it is an infinite operational design domain. If you think about the number of pixels that an image has and the possible values that this pixels can take, we are thinking about an infinite number of possibilities. But it's important that we start to define these and that we make sure that our system is not biased towards, a specific environmental condition versus another, right? Because, in that situation, my system might not behave well if there's fog or if there's snow or if there's something else, right? So here's where we start. When we think about data, we start with the operational design domain. Then we start thinking about, okay, how can I specify requirements for the data? Am I adequately capturing a good coverage for the data set? How about the combinations of data requirements? So for instance, do I have, if I guess in this previous situation, I was thinking of environmental conditions, maybe lightning conditions, dynamic elements or something. What about if they are combined with each other? Because, we can have combinations and so you need to start exploring how well you are designing the system by means of looking through the data. Because at the end of the day, an AI model is just a compressed version of the data that you have available, right?
Exactly. You mentioned the W model. What does it mean now for your software, for the process? What needs to be changed because you have not a V model approach now, you have a W model approach?
Yeah, a slight clarification. Yeah, I think, it's important to note traditional V&V workflows where MathWorks has had a lot of success in the past and offers a range of products. These are necessary, right? These are definitely necessary. They're not sufficient though when it comes to AI, right? So what we are seeing is that there is this concurrency of a workflow where if you're dealing with traditional item or a traditional component, you should follow the V cycle. If you are dealing instead with an AI component, you're going to be better equipped by following the W model.
And what does it mean now for the software, for your product?
Yeah, and so for the product, what it means is that we've been working on tools for each of the steps in the diagram. So for instance, when it comes to the novelty or the big change in the W, which is the peak of the W, right? We have developed tools like a deep learning toolbox verification library. And this is one of the projects that I've been more excited about in the recent years. It's a tool that allows you to verify and test the robustness of your AI model. And I think robustness is something that it's important.
But what does it mean, robust? Is there a clear definition? What is a robust model? No, I'm not sure.
Yeah, I have to apologize because also it's one of these marketing buzzwords that is sometimes it's used a lot, and I think it has a good definition. So robustness is really one of the main concerns when you're deploying a model or deep learning model, maybe in a safety critical situation. And the reason is that it's been shown that given a trained network and provided you can make a small perturbation to the network, that small perturbation might change the output of the network. And I guess it's important to understand that we're not going to have a trustworthy model if just by changing a pixel we get a different output, right? So that's how we start to define robustness. We start to define, it can be formally defined through an L infinity norm and changes in the input space, and so the idea basically is that if we look into again, back to me being a visual person, if we go back to the images example, right? If you think about an image and you think about a perturbation for that image, and think of a perturbation in an abstract way, right? So changes to that image, and this perturbation might define a collection of perturbed perturbed images for this specific image, right? So for example, just to give a simple example, if you have, let's say, an image of some component, right, going through a conveyor belt, and you're trying to predict maybe some sort of defect, right? You have an image, and then what you can do is you can define a perturbation of an L infinity norm of 5 pixels. And what does this mean? This means that given your image, you can add or subtract any number between, we said 5, right? Between 5 and -5. Okay, any number between, you can add any number from 0 to 5, continuous value, or subtract any number between 0 and -5, and to any number of pixels, right? Any combination of pixels. And so you can do it for 1 pixel, for 2 pixels, for 3 pixels, for all pixels, for whatever combination you'd like. And if you think about this process, the number of images that you're dealing with is infinite. It cannot be enumerated. It's just not feasible to enumerate all these changes to that image and pass that through your, define it as a test set and pass it through your network. It's just not feasible. Cannot be done. So instead, what we are doing with our deep learning toolbox verification library is we use formal methods. Formal methods that traditionally had been used to prove correctness of code can also be used to prove if, given that perturbation, the output of the network is going to change or not for any given image within that perturbation. And so this is quite appealing, because when we think about AI model development, if I were to ask you, Robert, what would be the 3 things, right, that you would like your AI model to have, right?
Fast, efficient, and no updates.
All right, fast, efficient, no updates. Yeah, I think this is very well aligned with what I typically hear from colleagues, customers. They say, yeah, we want to be very performant. I want to be very, very accurate. And only every now and then I hear safety, and I want to be safe, or I want to have a small memory footprint because I'm deploying it in some resource constrained hardware, or some variations of that. But when I mention safety, then they say, oh yeah, and then I cannot have a triangle anymore, right?
You are the bad cop then.
No, I'm not bad cop. But yeah, this comes up, and it's quite exciting and interesting to see how this is something that we might have not thought about, or maybe something that we have in mind, but we feel it's not so important, but it often is. And it often is the case that we build the most accurate models with respect to our test set, but when we put it in production, it doesn't behave.
And that's a typical problem, right?
It is very typical. And this is where we're working on making sure that, through formal methods, you can build more robust models, because if you have a robust model, then if you have maybe some light perturbation in your factory, that light perturbation will be handled accordingly by the AI model that has been trained with robustness in mind. You might also want to have something like, maybe a runtime monitor sitting alongside with your AI model. And this runtime monitor is a very great complementary strategy. It allows you to actively watch, the AI system during operation, and tells you if the model stays or is not staying within some acceptable bounds.
So do you also provide MLOps pipelines then, or is it a totally different business?
We do provide MLOps pipelines. Yeah, this is definitely something we're working on. In this context of runtime monitors, I was more thinking in the space of deploying the runtime monitor alongside with the AI model. So maybe, if you're running an AI model at a factory and you have a PLC that's, maybe it's moving a barrier or something, it needs to work real time. And in this situation, maybe the runtime monitor, if running on the cloud or within a part of a larger MLOps pipeline, might not be able to act effectively, or might not be able to act on time. But yeah, we can do both. We can either deploy these runtime assurance systems in the device alongside with the AI model, or we can just have them as part of a MLOps pipeline.
Let me be clear. So your approach, your safety AI approach, is that your sweet spot when it comes to new business models? Talking about MathWorks, so because there's a lot of competitors to MathWorks, and is this the new angle for you to go into this whole safety topic?
So I think it's definitely one of the areas where customers have been more excited about. I can mention maybe a couple of the reasons why our customers choose our solution, right?
I'm sure you know that.
Yeah, so I think maybe the number one reason is code generation. So MathWorks and MATLAB, I think it's often viewed as a prototyping tool.
Yeah, exactly. Yeah.
A lot of people don't know is that many of our customers, of course, do prototype in MATLAB, do their prototypes in MATLAB and Simulink, but then they also move to production with our tools. And in this case, code generation is one of the key areas why customers choose us. And our tools basically automatically generate readable and portable optimized C++ code or C code and or CUDA code or PLC code, right, from the AI models. And that's perhaps one of the reasons. Some of the other reasons I can think of are low code modeling tools. Often engineers they don't have to be experts in AI, right? They didn't study a computer science course or a degree or they don't necessarily have to know why a specific or particular solver is not converging according to their data and the model they've designed. And so we build apps. We build these intuitive apps where engineers can just leverage low code tools and not necessarily have to become AI experts. And so I think that's highly valued. Labeling tools for extracting features, it's often complicated understanding, especially if you're dealing with, the frequency domain, it's often complicated understanding how to extract features in the frequency domain. I think, yeah, definitely AI V&V is one of the areas in certification, and the path to certification is not always easy. And definitely the simulation, the integration within larger system. Of course, when we think about AI models do not live on their own. They're not, they're part of a larger system, and they cannot live in isolation. So we need to make sure that, when we're developing, I think the system level simulation, we're able to integrate that. And MathWorks also provides, domain specific tools for predictive maintenance and wireless and audio and other applications.
So we talked a lot about, let's call it traditional industrial AI applications. You mentioned the lightning topic, right? And conveyor belts. But what's the situation when it comes to Gen AI? Lucas.
Gen AI, it's definitely the elephant in the room these days, right? Yeah. So we at MathWorks, we are actively working in the Gen AI space. So maybe just to provide some pointers, right? So it's clear that our customers, they build systems, right? And as part of the development of these systems, they might want to integrate generative AI models, right? So that can be done in multiple forms. It's no surprise that today we have the large corporations providing very 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 highly curated large language models, and we need to leverage on that. We need to make sure that our customers can leverage on that. And so for that reason, we build tools to integrate with existing offerings, right? Whether it's Llama models or OpenAI models or other models, we provide tools to make sure that our customers can integrate with these. And interestingly, we're developing these in the open. We are developing them on GitHub, and our customers can come there, can contribute, can submit pull requests, and so on. So I think that's very appealing. At the same time, customers can build their own models using our tools. So we have libraries like Deep Learning Toolbox and Text Analytics Toolbox that would allow you to build also these systems if you feel more comfortable in the MATLAB space or in the MATLAB domain.
So you build Gen AI systems, right?
Yeah. Well, we are not building the systems themselves, but customers can potentially set up a large language model or a small language model, and provided they have the data, train it, and then integrate it with the rest of their application.
Okay. What are the next steps for you, for your team, for MathWorks when it comes to safety and AI? What you need to integrate in the next steps?
So we're doing a lot of work in the space. Well, we're working in various different arenas, of course. We definitely we continue to work on the standards bodies, and are very excited about what's coming and hopeful that new standards can be released soon. So that's one area. We're working on making sure that we have, remember this, try the workflow thing that I was mentioning earlier, where we were, we decided to try the whole workflow. We published these examples, right? These end-to-end examples where customers can use as a template for their own work. So if you have, let's say, problem related to images, you can look into the certification example that we put together for a runway sign classification, for instance, and try to replicate that for your own work. We also released an example for battery state of charge that deals with signals. And so the goal is to continue to expand in this field where we are providing more, these end-to-end reference workflow examples that can be used as templates for your own work. And then we're expanding the tools, of course, right? The area of AI verification is an area of very active research, and we want to make sure that we are up to speed with the latest research. So we keep attending conferences like NeurIPS, for instance. We were at NeurIPS back in 2024 presenting with Collins Aerospace there on AI verification. We want to make sure that we're up to date with the latest research in the field, and we want to continue developing tools that our customers can use in this space. Perhaps I think one area is that I find it fascinating. It's integration with open source frameworks, right?
Mm-hmm, sure, but this was always a critical thing when it comes to MathWorks, right?
Yeah, I think maybe for some reasons, I think the community or maybe people within the different communities have think about MATLAB and Python as being exclusive, and I completely disagree on that. I think that the best approach is to explore integration of both MATLAB and Python. You get the best of both worlds. In MATLAB, you can call Python right from the command line. In Python, you can pip install the MATLAB engine and call MATLAB from Python. By integrating, like I said, Python models, for instance, or let's say Python model strengths in PyTorch or TensorFlow within the MathWorks toolchain, you can also leverage the best of both worlds. You can get access to the latest research in PyTorch, and you can also leverage an end-to-end solution for system-level design. You can simulate your model, you can verify it, you can generate code, and more.
Lucas, thanks a lot. It was a pleasure to talk to you about safety AI, MathWorks. I was surprised, really. I have to admit, I was not into this whole safety AI topic, and I was not aware that MathWorks is so interested in the whole topic. Thanks a lot for the interview. It was a pleasure.
Thank you so much, Robert, for having me.